Welcome friends. We have been doing problems on CSIR-NET, problems on sequences in series of real analysis. In fact, real sequences and real series. Now we solve a question which was asked in June 2011. The question is, if xn and yn are sequences of real numbers, which of the following is or true? We are given four options. Results pertaining to supremum and infimum of a sequence. So limit n tends to infinity supremum of xn plus yn is less than or equal to limit supremum of xn plus limit supremum of yn. The next result is limit supremum of the sum of the sequences is greater than or equal to sum of the limit supremums, limit subs. Similarly, 3 and 4 deals with the infimum. Limit infimum of a sum is less than or equal to sum of the limit infimums, and the fourth one is limit infimum of the sum is greater than or equal to sum of the limit infimums. Now from any analysis book you can find that these two results, options 1 and 4 are true. Limit supremum of xn plus yn is always less than or equal to limit supremum of xn plus limit supremum of yn. That is always true. That you can find in any of the standard analysis textbook. Likewise, fourth one is also true. Limit infimum of xn plus yn is greater than or equal to limit infimum of xn plus limit infimum of yn. Now we have to show that these two are false. These two are false. For that, what do we do is to prove some result as a false. What you have to do is you produce a counter example. To prove some result as false, what you have to do is we have to produce a counter example. So consider two sequences, xn is equal to minus 1 power n and yn is equal to minus 1 power n minus 1. Now we deliberately take sequences which are oscillating finitely, or we have to consider sequences which are not convergent, because in the case of a convergent sequence, limit infimum and limit supremum turn out to be the one and the same, which is equal to limit of a sequence. So this is an important point. So while giving a counter example, what you have to do is you have to consider a sequence which is not convergent. So that is what you have to consider, because in the case of a convergent sequence, I repeat, the concept of limit supremum and limit infimum and limit are one and the same. Therefore, it may happen that they may be equal for a convergent sequence. Okay. So what do we do is we deliberately consider a sequence which is oscillating finitely. So what is the limit? When you add xn plus yn, when you add these two sequences, what you will get is xn plus yn is minus 1 power n plus minus 1 power n plus 1. So when you where n belongs to natural numbers. So for every n this turns out to be 0. Therefore limit supremum of xn plus yn, limit supremum of xn plus yn is 0, because this is being a constant sequence, limit supremum is 0. And what is the limit supremum of this sequence? Limit supremum of this sequence is 1, because the terms of the sequence are oscillate, minus 1 plus 1 and so on. So limit supremum is 1 for the sequence xn, whereas limit supremum for yn is also 1. So when you add these two, 2, whereas the limit supremum of xn plus yn is 0. We are given that 0 is greater than or equal to 2, which is false. Therefore, option 2 is false. Likewise, what do we do is you find the limit infimum of xn. What is the limit infimum of xn? So when you consider the terms of the sequence xn, limit infimum is minus 1. Limit infimum is minus 1. So limit infimum of xn is minus 1 and limit infimum of yn is also minus 1. Therefore, but limit infimum of xn plus yn is equal to 0, because xn plus yn is equal to 0 for all n. So limit infimum of xn plus yn is equal to 0, which is less than or equal to limit infimum of xn plus limit infimum of yn. This is minus 1, this is minus 1. Minus 1 minus 1 is minus 2. So that's what we are getting, but which is false. 0 is less than or equal to minus 2 is false. That cannot happen. Therefore, option 3 is also false. Option 3 is also false. The correct options are 1 and 4. They are the only two correct options. Okay.